let's go ahead and take a look at one more example here. We're going to use implicit differentiation to find y prime for the equation 4e to the 2x plus 3y power plus 4y cubed is equal to 15x squared minus 8. So as usual, my first step, I'm going to take the derivative of both sides of my equation. Now when I look at this first term, this 4e to the 2x plus 3y power, here I have e to the 2x plus 3y power. Hopefully we can look at this and think, hey, that kind of looks like a chain rule. And if you thought that, you are absolutely right. Remember the derivative rule for the chain rule, if we have, say, y equals e to the u power, the derivative of that would be y prime equals u prime times e to the u. So I'm going to have to multiply by the derivative of this power here when I take my derivative. So let's see, we will have u prime, so the derivative of our power, so the derivative of 2x is just going to be 2 times plus the derivative of 3y. Here the derivative of 3y should just be 3, but again, we're thinking about y as a function of x. We need to use our chain rule, which means we need to multiply by y prime, the derivative of the inside part. So there's my u prime. 4 is just a constant multiple, so that's just going to come down, and then e to the u, so e to the 2x plus 3y power. So like I said in the last video, implicit differentiation still works with the product rule, the quotient rule, and the chain rule. If we run across one of those scenarios, we will still have to use that rule. So we use the chain rule here. The rest of it shouldn't be as bad. The derivative of, let's see, our next term, 4y cubed. Here we can just use our power rule. That's going to be 12y squared. But again, we are using a chain rule here because we have y as a function of x, which means we need to multiply by y prime is equal to, over on that right-hand side. Here in this case, I do have something that's non-zero over there on that right-hand side of my equation, so I am going to have to take the derivative of that. So in this case, let's see, 15x squared would just be 30x. And then negative 8, that's a constant, so its derivative is 0. So this is what I've got right now. I've got 2 plus 3y prime times, all of that times 4e to the 2x plus 3y power plus 12y squared y prime is equal to 30x. Whew. Now, there's a lot here. It's kind of messy. Now we want to isolate y prime, which means we want the terms that have a y prime, we want to keep those on one side of the equation. Everything else we want to go ahead and move over to the other side. In this case, we are going to go ahead and have to distribute this 4e to the 2x plus 3y power to both terms here. So when I do that here, 4 times 2, I should have 8e to the 2x plus 3y power, plus 3 times 4, I should have 12 y prime e to the 2x plus 3y power. So all I did was distribute that 4e to the 2x plus 3y. Everything else is going to stay exactly the same. So 12y squared y prime is equal to 30x. So now I see here my two y prime terms. I've got those by themselves, which is really nice. I'm going to go ahead and then just move this 8e to the 2x plus 3y power. So we'll subtract that from both sides, giving us 12y prime e to the 2x plus 3y power plus 12y squared y prime equals 30x minus 8e to the 2x plus 3y power. So this looks messy and it looks like there's a lot of stuff going on here, but if we just keep in mind, hey, I want to get y prime by itself, we're actually pretty close to the end of this problem here. Since both terms on our left-hand side have a y prime, we can factor that y prime out. So that's going to be our next step. We factor out y prime, and that will leave us with 12e to the 2x plus 3y power plus 12y squared equals the other side we're not doing anything with. That's going to remain exactly the same here. Now, okay, what are we trying to do again? We're trying to solve for y prime, which means we just need to divide by whatever we're multiplying y prime by, which in this case is that stuff inside the parentheses. So we're just going to divide by that. And our solution, our derivative, will look like y prime equals 30x minus 8e to the 2x plus 3y power divided by 12e to the 2x plus 3y power plus 12y squared. And there is our derivative. If you wanted to stop there at this point, I think that's fine. We could, let's see, we could factor out a common factor of 2, it looks like. I don't think it's really worth it here in this case. This has already been a pretty challenging problem, so I would probably stop right there. But if you wanted to factor that 2 out, just to kind of show that real quick, in my numerator we would factor out a 2. We've got 15x minus 4e to the 2x plus 3y power all over 2 in our denominator. Let's see. That would be 6e to the 2x plus 3y power plus 6y squared. And then we can go ahead and cancel that common factor of 2. So either one of these I think is perfectly fine as your answer. When it comes to simplifying these, I'm not worried too much about factoring and simplifying. I'm more worried about, can we find y prime using this new process, using implicit differentiation? To me, that's what I would really, really like to focus on in these examples.